Now let us talk about a very important category of function, that is nothing but lambda functions. Okay, so I will spend some time here so that you understand this thing, and for this we will be developing a function called sum of integers. First we will start with this. I am developing a regular function. It's not a lambda function, it is a regular function. Regular functions should start with the def and then the function name, and in this case the functionality of the sum of integers, I'll be defining two arguments, lower bound and upper bound. Okay, and I want to add all the values between lower bound and upper bound and print the results. So there are two ways to do this. One is using the formula. So for example, if I pass 1 to 100, okay, so I am trying to get sum of integers between 1 to 100. I can use n multiplied by n plus 1 divided by 2. Okay, this is the effective way of getting sum of integers. If I want to get from 4 to 100 or 5 to 100, so I have to get sum of integers from 1 to 100 using this formula, 100 times 100 plus 1 by 2, and then I have to subtract, okay, sum of numbers from 1 to 4. Okay, and hence what I have to do, 5 minus 1, which is nothing but lower bound minus 1. This should be the formula. If I am using LB and UB, the formula has to be UB times UB plus 1 divided by 2. Okay, and that will give from 1 to 100, and then you have to subtract 1 to 4. Okay, so what you have to do, you have to use lower bound minus 1, I have to put it in brackets, lower bound minus 1, and then multiplied by just lower bound divided by 2. It will give 1 to lower bound or 1 to 4. And then we will get the sum of integers between 5 to 100. This is one approach where we can compute sum of integers between lower bound and upper bound. And the other approach is to iterate through numbers from 5 to 100 and add one after the other to a variable which is defined as total, and then return the total. So these two are the approaches which we can develop, and the efficient way is by using function. By using function, if you look at the function, we hardly perform 10 operations irrespective of number of values we pass. But with looping, depending upon the number of values we are processing, we have to loop those many times, which means we have to perform those many operations. For example, if I have to add 1 to million, in each iteration I have to add the value to the totaler. Plus is one operation and equal to is another operation. Assignment is another operation. So for each integer between 1 to 1 million, I have to perform 2 operations, and hence total I have to perform 2 million operations. But with formula, whether you are processing 1 to 1000 or 1 to million, you are only using 10 or 15 operations, not more than that. So using formula is a lot more efficient. Even though it is not efficient, I will be using looping just to explain the lambda functions. That's the only reason why I am using lambda function. And the reason why I have explained using formula versus looping is that is how you should actually evaluate multiple solutions to determine which solution can be better or other. Okay. So to begin with, I will just develop it with formula, and then we'll go back to looping, and we'll continue with looping to understand the lambda functions in detail. So in this case, I'm creating a variable called L, and I'm saying LB minus 1 because first I have to get UB. Using UB, I have to get sum of integers. So if I pass 5, 100, first I have to get the total sum of numbers from 1 to 100. And how to get that? I can say UB multiplied by UB plus 1. Okay. After getting UB multiplied by UB plus 1, I can divide by 2. Okay. So this one will give the sum of numbers from 1 to UB, right? And then I have to say minus. Okay. Using L, I have to get sum of numbers till L. So I can say L multiplied by L plus 1 divided by 2. So this one will give sum of integers between 1 and lower bound minus 1. Using this formula, I can return and hit enter. And then I can invoke sum of integers between 1, 10. I have to use sum of integers as function name. I will use 2 spaces for indentation. Even for return statement, I have to use 2 spaces here. Now let me use sum of integers to invoke this, and you can see we got 55, which is correct. If you just want to return as integer, you can typecast integer. That is fine because we are using all integers, so it should be always be integer. So if you want, you can actually typecast integer. Now let me try with some other range, 5, 10. 5, 10 is nothing but 45. You can see the value is correct. Okay. This is how you can actually build using formula to get sum of integers. But to demonstrate lambda function, we will be using looping, and to use looping, we will be using range. So if I say range of 1, 10, it will give values from 1 to 9. If I want to get the upper bound also, I have to use range of 1, 10 plus 1. Then we will get numbers from 1 to 10. If it is 5 to 10, I have to say range of 5 comma 11. Okay. Now I am creating a function called sum, passing lower bound and upper bound. So to use looping, first we have to create a variable to which we want to add the values. I am creating a variable called total only to demonstrate lambda function so that you understand those things. I am using this approach. Otherwise, this is not the right approach to get sum of integers. You always should fall back on formula. Formula is a lot more efficient than looping. Okay. So here for I in range of LB comma UB plus 1, I am getting all the values from lower bound till upper bound by using this, and then I have to add the dice to total like this and then return total and hit enter. Now you can actually say sum of 1 comma 10 and you can see 55. You can also say 5 comma 10 and it will give 45. Okay. So now you understand how to get sum of integers between a given range. Let's say I want to implement sum of squares of integers or sum of cubes of integers or sum of multiples of 2's between a given range. There are multiple ways to come up with the solution. In one approach is, apart from lower bound and upper bound, you can also pass third argument what you are trying to do, whether you are trying to get squares or cubes or multiples of 2's, and you can write the logic as part of the function. If the third argument is sum of squares, you square the number before adding to total. If it is sum of cubes, you cube the number before adding to total. If you pass multiples of 2's, you multiply with 2 before adding to total. That logic has to be developed. Or another alternative is to create 3 different functions. One is to add the numbers between the range. Second one is to add the squares of numbers between the range, and third one is to add cubes of numbers between range. These two are the approaches which we can typically follow, but with programming languages like Python, Scala, etc., there is a third way of expressing the logic, and that is what lambda function is. And using lambda function, you don't need to give names to the functions, and using that approach, you can actually pass a function as an argument, and as part of passing function as an argument, you can actually eliminate both the approaches and come up with the solution. Let me give you an example and we will see. So in this case, as part of sum, on top of this lower bound and upper bound, I will be passing third argument called f, and f is of type function. It is not integer like lower bound and upper bound. It is a function. Okay. And while defining the function, here we are defining something called higher order function. Sum is a higher order function, and here I am saying total equal to 0. I am initializing total to 0, and this also same for I in range of LB comma UB plus 1. Okay, and this is where it will differ. So here we are saying total plus equal to f of I. So f is of type function, and f will take one argument, and we are invoking that. So here we don't know what f is, but while invoking the function sum, we will tell what the f is, and then it will invoke that function at runtime, and it will get whatever it is supposed to, and then that value will be added, and then finally return total. Okay, so this is how you define the function. So instead of 2 arguments, we define with 3 arguments. The third one is function. So we are just saying that at runtime, while invoking this higher order function called sum, on top of regular arguments such as lower bound and upper bound, which might be of type integers, I'll be passing a third argument which is of type function, and that function will be invoked as part of the logic, and I have developed logic accordingly. So as part of the logic, I am invoking that function. So we don't know what this function is. We have to pass when the sum is invoked. So let's see how we can use it. So let's say sum 5 comma 10. Okay, so the first 2 arguments are 5 comma 10, and the third argument has to be lambda function. Lambda function means a function without name. So we are passing a function without name, which means we are passing the logic without defining a function here. So all we need to do is we say lambda, and here we need to pass arguments to this lambda function. So this function which is being invoked at runtime takes one argument, and what is the type of the argument? It is of type integer, right? So we have to pass that, let's say lambda I, and here to get just sum of numbers, I just have to return the same number. So I'm just saying I. So here I'm actually passing the logic also. Okay, so in this case I'm just returning whatever I'm passing to that function and hit enter, and you can see we got 45. So what is happening at runtime? We are passing 5 comma 10 and lambda I colon I. So we are actually saying we are defining functionality for this function f. This f will be replaced with this lambda I. So this I is nothing but return value. Okay, so at runtime in each iteration it will pass 5, 6, 7, 8, 9, 10, etc. to this function, and as this function is returning whatever is passed to it, that value is being added to the total and it is returning here. If you want to see the values, you can actually say def total equal to 0 for I in range. Let's say print f of I total plus equal to f of I, and then return total, and then you can say sum of 5 comma 10 lambda I, and you can see in each iteration it is passing 5, 6, 7, 8, 9, 10, and those are being added to total, and you can see the total 45 here. Now if I want to get square of integers, I just have to say I times I. Okay, so whenever this function is invoked, it is actually, that means at runtime, when we pass 5 comma 10 along with the functionality, which is nothing but returning the squares, it actually invokes this function by passing the I. So it can be any name. So the argument name can be anything. It need not be I itself, and we are just squaring this number and returning it. F of I will get that number, and we are adding that number to total, and we are getting the result. Similarly, if I want to get multiples of 2s, I can do that also here. If I want to get cubes, I can pass cubes also. If I want to just get even numbers, I can develop something like this. I if I mod 2 equal to 0, else 0. So in this case, it will only add the even numbers. So 5 we replace with 0, 6 we got 6, 7 we replace with 0, 8 we got 8, 9 we replace with 0, 10 we got 10. So only 6, 8 and 10 are added, and we got 24. So the beauty of this is we can actually tell what should be the logic that needs to be executed at runtime. So that being said, there are certain limitations with respect to Lambda functions. You can only write single liners like this. If you want to write complex logic, you have to create a main function, and you have to invoke that function. For example, in this case, sum of even numbers, if I want to define a main function and invoke that, I have to just say def get even, okay, and then it takes one argument, let's say I or n, and then I can say return n if n mod 2 equal to 0, else 0, and we define the function get even, and we can actually say sum of lambda I get even of I, and hit enter. Okay, we can also invoke the named function if the logic is a bit complicated. Okay, sometimes we have to do this, and you will understand at a later point in time. For now, just understand the significance of Lambda functions, syntax of Lambda functions, and how it works functionally. It is very, very important for you to learn Spark. If you fail to understand Lambda function, then you will not be able to understand the MapReduce APIs